I'm Dugas. In previous videos we looked at all types of rational functions, and now we're going to learn how to analytically solve rational equations. 5 over 24 plus 2 over 3 minus x equals 1/4. And of course we're always going to try to check our solution if we have time. So what I have to do when I'm solving this equation, notice I'm adding, so I am going to have to get a common denominator here. Lowest common denominator I can get, since 4 goes into 24, 24 is 4 times 6, then the lowest common denominator is going to be 24 times 3 minus x. So as we've talked about previously in adding and subtracting rational functions, we need to do that here. So 5 over 24, what it's missing is the 3 minus x. And if you're unsure of how to do this, go back to the 8.2 video, which is on how to add and subtract rational expressions. So 2 over 3 minus x, what it lacks is the 24. And what the 4 lacks is a 6. And then the 3 minus x. All of these will give you that common denominator of 24 times 3 minus x. So when I multiply this all out, on the left side I get this big denominator of 24 times 3 minus x. And in the first term I have 15 minus 5x. The second term I have plus 48. Over here, same denominator. And when I distribute the 6, I get 18 minus 6x. So since the numerators are the same and the denominators are the same, we can set the numerators equal to each other and solve for this. So combining those like terms, we get 63 minus 5x in the left-hand numerator equals 18 minus 6x in the right-hand numerator. So we add 5x to both sides and subtract 18 from both sides, and we're going to get that 45 on the left side equals negative x, which means that when you divide by -1, x equals negative 45. Now we should always, in algebra and any type of mathematics, go back and check our answer when that's possible. We're going to take a negative 45 and plug it back into the original equation. So we get 5 over 24 plus 2 over 3 minus negative 45, and that better equal 1/4. And so 5/24 plus 2 over 48, which is in fact 1 over 24, better equal 1/4. Well, that becomes 6 over 24ths, and 6/24 is in fact equal to 1/4, so it checks out, negative 45. Let's do a more complex example. So we've got x over x minus 2 equals 2 over x plus 4 minus 2x over x squared plus 2x minus 8. First thing you should try to do before you go after common denominators is try to factor. So let's look at this, because this trinomial may involve these two binomial terms. And in fact, if you factor x squared plus 2x minus 8, it does in fact factor to x plus 4, x minus 2, because 4 times negative 2 is negative 8, and then 4 plus negative 2 is positive 2. So in fact, both of these terms are already in this trinomial. So that becomes the lowest common denominator. So what we're going to do is multiply each of the terms so that we get that lowest common denominator, and which means we need to multiply the first term by x plus 4. That's what it's lacking, that left-hand side. And then we're going to multiply that second term, the 2 over x plus 4, times x minus 2, because that's what it's lacking. And that last term doesn't lack anything. It has the entirety of the LCD. Okay, so now let's go ahead and distribute everything out. When we distribute that left-hand side, distributing that x, we get x squared plus 4x. This term, the 2 over x plus 4 term, when we distribute the 2, we get 2x minus 4. And then there's nothing to distribute here. We have the 2x. Okay, so since the denominators are the same, we can set the numerators equal to each other. X squared plus 4x on the left-hand side equals 2x minus 4 minus 2x. Notice the 2x's are going to cancel each other out when we combine like terms. And so we wind up with x squared plus 4x equals negative 4. Now, you will recall from quadratics, I hope, that this is a quadratic. We need to move the negative 4 to the left-hand side by addition. And we're going to get x squared plus 4x plus 4 equals 0. Now, we need to look and see if that factors. In fact, it does factor. This becomes x plus 2 times x plus 2 equals 0. And so in the end, this becomes only one solution, x equals negative 2. Now, of course, we need to check that out. So let's check it out by putting negative 2 into the original equation. So I put the checking the solution just to save time in the screencast over here. Let's look at a very typical type of problem using this type of function. And that's a work problem where two or more people are working together. So Wade and Emma are mowing lawns together. Wade by himself could do this in 4 hours. Emma, she's a little bit better at it. She could do it in 3.5 hours. How long does it take them to work together on the job? So if we look at Wade, Wade can complete 1/4 of the job in 1 hour. Emma could complete 1 over 3.5 parts of the job in 1 hour. So together, they could do that same fraction in x hours. So we're going to set this up like a rational equation, which it is. So we have 1/4 plus 1 over 3.5 equals 1 over x. Okay, so I'm going to try and get a common denominator here, and really what I'm just going to do is multiply them together. So 1/4 I'm going to multiply by 3.5 over 3.5. And then the 3.5, 1 over 3.5, Emma's portion, I'm going to multiply by 4 over 4, just to get that common denominator. I'm going to leave this as 1 over x. And so I get 3.5 plus 4 over the common denominator of 4 times 3.4, which is 14, is equal to 1 over x. So 3.5 plus 4 is 7.5 over 14 equals 1 over x. So what I can actually do now is cross multiply here, get 7.5x equals 14. So together, they can finish the job once I divide by 7.5 in 14 divided by 7.5 hours. So 14 divided by 7.5 is 1.87. So they can finish it together in 1.787 hours. This is a rational function, a rational equation. So we've looked at how to solve rational equations and using them to solve problems like the work problem.